So welcome, folks. This workshop series is designed to help you hear from and connect with active researchers in varying computing disciplines. And we really want to try to kind of have a diverse group of different subdisciplines because computing research is a very wide umbrella. So as you go through these different workshops in the series, hopefully each time you'll learn about some stuff that you just didn't even know existed before, kind of give you a very broad lay of the land. So through these workshops, you're going to be able to participate in lively discussions on research-related topics, learn more about research career options, and expand your professional network. So some disclaimers, these workshops are being recorded. I think you hopefully saw notifications saying that the meeting is being recorded right now. We are going to be saving these, and they're going to be used for informational, educational purposes only. CRA does not make any representation or warranties with respect to the accuracy, applicability, fitness, or completeness of the contents. It's really just focused on kind of getting the opinions of the folks on this panel. So as anyone's opinion, take everyone's opinion with a grain of salt because, as always. So yeah, just fair warning. The information contained in this workshop represents the views and opinions of the individuals and does not necessarily represent the views or opinions of Computing Research Association or any of the organizations that our speakers or participants are affiliated with, just to kind of make sure that disclaimer is out there. So yeah, just to kind of introduce the CRA team that's going to be behind these workshops, my colleague Christine Bassam and I are design facilitators. My name is Nima Moshiri. And then we also have Julia Sepulveda Avalos, who's our program associate. She's been kind of leading, organizing the background of all this stuff. So we really appreciate all the hard work that she's done to make this run smoothly. Yeah. And if you have any questions, we have our email on the previous slide. We can type it in the chat later as well. But yeah, we would love to hear from you.
All right, so today's session. So this is our inaugural session, session 1, which is titled, So You've Done Some Research, What's Next? For this session, we have grouped an amazing set of panelists who have done computing research or who are still doing computing research. And the idea is that they will talk about how, how that research they've done, has impacted their life or, how they got to where they are and the path that they've taken. So let's, present the panelists, and thank you for everyone. So all the panelists have their videos on, so you can see them in the video, and you also can see them here in this awesome slide. So Celeste Bean is a senior hardware engineer at Sony PlayStation. We have Dr. Roman Caudillo, who's an Intel researcher currently at SRC as Jump 2.0 director. And we have Dr. Catherine Delcourt, who is an assistant professor at the computer science department at Wellesley College. And we have two amazing undergrads, Daniel G., an undergrad researcher at UC San Diego, and Sophia Kobayashi, who is an undergraduate researcher at Wellesley College. So what we're going to be doing in this session, we're going to start the conversation. Please feel free to ask your questions in the Q&A, please. So I'm going to have both the chat and the Q&A open, but my request is please use the Q&A so we can have everything in one place. All right. Thank you. And we will now stop sharing the screen so that we can have our panelists, start the discussion and have, get this discussion going. All right.
Awesome. So, and sorry, I should have pulled it up beforehand. So I guess the first thing that I'll ask is maybe we can go around and sorry, I'm pinning everyone as the spotlight so that all the participants can see. But I guess my first question for folks, and maybe I can just kind of go down the panel and ask folks, is just, could you introduce yourself? So maybe let us know your name and your affiliation, and some insights into what types of stuff you do in your current position. So maybe I'll call people to avoid confusion. Roman, do you want to go first?
Yeah, sure. Hi, everyone. Good to meet you. I am Roman Caudillo. You can also call me Roman. Either one is fine with me. A bit about myself. I was born in Mexico City, and I came to the U.S. when I was about 5 years old. So, all of my schooling has been in English, but I am, I guess, first-generation immigrant, and my children would be first-generation Mexican-American. I am a researcher at Intel. Most of my career at Intel, I've been at Intel 17 years. Most of that has been in components research, which is the manufacturing, the advancing Moore's Law, the working on devices. More recently, about 2 years ago, I started managing research. So after doing, 15 years of research now, managing our investments in university research. And so at the beginning, when you saw leading Jump 2.0, that's a big consortium of researchers across the whole country. It's 140 researchers with 42 universities. So kind of a little bit of a new role for me, but hopefully I can apply all of my years of doing hands-on research now helping direct research of a big program. So that's a bit about me, and I look forward to participating on the panel. Thanks for having me.
Yeah, thank you for joining us. Maybe Celeste, do you want to go next?
Hello, my name is Celeste Bean, and I work for PlayStation R&D, part of Sony larger corporation. And what I do is I think about how people interact with digital media, and a lot of the projects that I lead involve thinking about how if we change our physical interaction, what kind of new experiences can that create with digital media, both games specifically and more broadly. And so that involves things relating to machine learning, thinking about if you could speak to a controller, how might that change your gameplay? If you could completely change the form factor of a controller, how might that do it? If we think about how to make game controllers more accessible, what might that look like? How do we expand the audience, and how do we include more people in our gaming? As far as my education, I went to UC Santa Barbara and did my undergrad in computer engineering, and then did a master's in electrical engineering, which is actually because I dropped out of the PhD program. So I'm happy to talk about the alternatives, the wiggling, waggling you can do in thinking about research. That's me.
Yeah, thank you so much. Yeah, great to have you here. Thank you. Catherine, do you want to go next?
Sure. Hi, everyone. I'm Catherine Delcourt. I'm an assistant professor in the computer science department at Wellesley College. I also happen to be an alum from Wellesley, so this is where I did my undergrad. And then I did my PhD in computer science at Georgia Tech. And my research areas, so at Wellesley, there are a lot of different types of colleges and universities. Wellesley is pretty heavily teaching focused, so a large part of my time is focused on teaching, and I teach classes in the wide range of computer science. I also have some time to do some research, which is in human-computer interaction, or more specifically, social computing. And I'm happy to talk about a number of different projects in that area, but I also have some industry experience. And my industry track is what's called user experience research, which is a specific research application within UX. So happy to talk about any of that.
Awesome. Thank you so much. Thanks for joining us. Daniel, do you want to go next?
Yeah, sure. So hi everyone, I'm Daniel. I'm a second year here at UCSD studying computer science, and I do research under NEMA, and that's mostly related to web development and bioinformatics. So, and I guess the main focus I've been working on for the past year or so has been taking bioinformatics tools and porting them over to the web. So that tools that you'd usually run on the command line in your computer, now they could be run in the web. But yeah, aside from that, I'm also doing or helping build the web apps for UCSD's ITS team. And yeah, it's fun.
Awesome. Yeah, thanks so much, Daniel. Thank you. And Sophia, do you want to go next?
Yeah, definitely. Hello, everyone. My name is Sophia Kobayashi. I'm a senior at Wellesley College, studying computer science. I've actually done research with Professor Catherine Delcourt and Christine Bassam for 2 years now with Catherine, and then more recently Christine. So a lot of my research has focused on human-computer interaction with Catherine, specifically like social computing, and looking at like communities and relationships within them, and if you can map them out, how we can recreate them even. And then with Christine, we've been looking at like user task matching algorithms in like spatial crowdsourcing, which is just like, how do you match people with tasks when they have to move around? What are the trade-offs? What are the benefits? That's me. Nice to meet you all.
Awesome. Thank you so much, everyone, for introducing yourselves. And, hopefully, audience, you saw we have a very wide range of very cool research areas. So, hopefully the creative juices are flowing. Definitely keep some ideas in mind. We will be monitoring the chat. So if you have any questions that you want asked later, I'm going to start with some pre-prepared ones, but definitely feel free to throw them in. And maybe like 20 minutes from now or so, we're going to switch over to asking audience questions. So I guess first, just to kind of get the conversation started, all of you are in very different research areas and you're doing a lot of cool stuff, but let's kind of dial it back to the very beginning. What kind of first got you interested in that specific research area that you're currently working in? And maybe I'll just throw this to the audience, but I don't know if, folks can feel free to unmute if they want, or I can call on folks if multiple people want to raise their hands. But yeah, what got you interested in this research area from the very beginning?
Well, I can go first, Nima, if no one else is ready. So if I flash all the way back for me, I remember being a freshman undergraduate, and I still wasn't sure what I wanted my major to be. And that first summer, I got an internship at a company. It was called Carbomedics, and they made artificial heart valves. And for me, it was a bit of good fortune that I got to work with some of the R&D engineers that summer there. And I mean, by the end of that summer, I was 100% decided that I wanted to be an engineer, right? So I think for me, that was the first step. I didn't know I wanted to go to graduate school. That came later. But that to me was kind of the first critical domino to fall in that direction. I went and got my bachelor's in mechanical engineering, really interested in material science already at that point. And then I came out of undergraduate and I wanted to be independent, start working. That led me to a job at Applied Materials in Austin. And, Applied Materials is a well-known company, makes semiconductor manufacturing equipment. And in Austin, they have their manufacturing facilities. And but you get exposed to the whole big corporate environment. And it only took me about 6 months to realize, oh, all of the cool jobs from my perspective required a graduate degree. So like it just solidly planted in my mind, oh, if I want to be doing these things that are super interesting to me, I need to keep going. And it took me about another year and a half, and actually even a stint at another company before I was able to make my way back to graduate school to get my master's and PhD in material science at UT Austin. But I would say those two pivotal events for me is just one, to see how much I was inspired by an engineering R&D type of job, even if it was an internship, and then add a full-time job to see that the jobs that resonated with me were research jobs that required a graduate school degree.
Oh, that's awesome. Yeah, thank you so much for sharing, Roman. Yeah, Celeste,
Sure.
Please go for it.
Yeah, I would say that for me, I had kind of a different in exact stages, but similar motivation of wanting to go deeper, wanting to explore things. But what I focused on specifically really meandered. So I kind of want to tell you a little bit about that, because I knew that I liked the act of research and of going deeper and of trying something new and of being frustrated with a problem. But I went all over the place to get to where I am now. So I think between my sophomore and junior years of undergraduate, I applied for a Department of Energy scholarship, which basically lets you go work at a national lab. So that's called the Sony Scholarship Science Undergraduate Laboratory Internship. And basically stalked someone who worked at Los Alamos National Lab and said, hey, can I come work for you? I have funding. And he said, yeah, I guess. And so I started working on basically 3D modeling for antibiotics. I did that, decided it wasn't for me, met someone else at Los Alamos, did the same thing the next year, worked on quantum cryptography, realized that was kind of cool, but I was more interested in the power grid, didn't want to do quantum cryptography anymore, and then went and did my master's and focused on electrical engineering and how to get basically solar panels to integrate into the power grid better. So I did kind of my graduate education focusing on that research and did a stint at the National Renewable Energy Lab. Went to go work in industry, didn't like that, and then finally came back to do some more industry research as I am at PlayStation. And so what I focus on specifically has meandered all over the place, but what I think has been constant is looking for the opportunity to apply research as a skill set, which I think when I was younger, I did not appreciate as being a fundamental skill set. I thought it was applied to topical areas.
That's awesome. I mean, I think that touches on a great point of like, you don't necessarily need to know exactly what topic you want to do from day one. And I was in a similar boat that I was kind of all over the place throughout all aspects of my life.
Yeah, thank you. I also wanted to, oh, sorry, go ahead.
No, yeah, go for it.
No, I was going to say, I love that also the point that you made, Celeste, that the skill set, what you're getting out of, doing research or going into graduate school is really, you learn a certain set of skills, and you can apply those in so many different ways. Well, thank you. Go ahead.
Absolutely. Yeah. Anyone else on the panel? Anyone else want to jump in? Yeah, Catherine, please go
Sure.
for it.
Yeah, sure. I think for me, I started just undergrad not knowing anything about computer science, started taking a few classes and really enjoying it. And in my sophomore year, getting connected with someone who was a UX practitioner, which wasn't a big thing back in the day. This is like 2007-ish. And so learning more about the mix of psychology to understand technology really drew me into HCI. I knew pretty quickly that that was the direction I wanted to go in. And so I guess more circumstantial getting into research just because those were the opportunities that were there to learn more about HCI. This was back in the day when companies didn't come to schools like Wellesley to do internship recruitment. That wasn't a thing. Only banks did that. So it was either an internship at a bank or doing a NSF funded REU type program, which sounded so much more appealing to me. So I did a few of those for a few summers following my sophomore year. I did it sophomore summer, junior summer, looking at NSF REUs or the DREU program through CRA, I think actually. And so a number of different research opportunities like that, getting connected then through those to faculty at larger research universities, getting to meet grad students and all of the research that was happening in those places in HCI. And then as a senior, getting involved in recruiting a faculty member for Wellesley College focused in HCI, who's now the chair of our department. And so getting really involved in that way, in that aspect of research, just because I was very driven by wanting to understand how to make technology better for people. And those were where the opportunities were at the time. What happened to me, which, this is a cyclical thing, but I graduated in 2009, when at that point looking for an industry job was not a thing, really. And so PhD, just following with the research I had been doing over the summers and my undergraduate thesis, just all of those pieces lined up for the PhD being the track I was going to follow, I guess. So that's kind of how I went into research, and just continuing with that. And one thing I feel strongly about is that through the PhD or through continuing a research track, it's always great to try both sides, getting a chance to do internships and seeing the industry side, or as an academic, getting a chance to collaborate or continue working with industry partners and kind of vice versa, because research is across institution and very collaborative.
Awesome. Yeah, thank you for sharing. And there was a great question in the chat that I'll just bring up. Could you maybe explain, because you mentioned the term REU and DREU. So for students that maybe are in the audience, could you explain like what are those and how did they help you and whatnot? Just a short overview.
Sure. REU stands for Research Experience for Undergraduates, which I believe are NSF programs that have that specific REU label. And then DREU stands for Distributed Research Experience for Undergraduates, which is through CRA, I believe. They are structured in different ways depending on the places, but I would strongly recommend anyone interested in computer science research to look on the NSF REU page, because they list all the different programs that are available. And this is the time right now when they're hiring for these. They happen during the summer. They're funded through the NSF, so you'd get some stipend and live on university campuses for the summer to do that research. And then each program structures it in different ways. I did one at Virginia Tech in their Center for Human-Computer Interaction. So it was all the faculty member doing research in that area. And there were about maybe 20 of us undergraduate students who we had, like in the mornings, we had class sort of on HCI and different topics and doing research. And then in the afternoons, we did research with the faculty members and their specific labs. But all sorts of different REUs are structured in different ways.
Awesome. Yeah, thank you for sharing that. I do have more questions. I don't know if Daniel or Sophia, if either of you wanted to jump in as well. Yeah, Sophia, please go for it.
Yeah, I'd love to.
I'm
So yeah, my
sorry
group-
sorry to interrupt. I'm so sorry to interrupt. There was another related question. So do you guys mind if I just quickly interrupt? Someone was asking about the REUs and DREUs, if it's open to everyone or only US citizens. So sorry, Sophia.
I don't know. I think it might depend on the program too. So you
Yeah,
need to, yeah.
I think the details would be on the REU itself. Yeah.
Yeah.
Thank you. Sophia, sorry,
Awesome.
go ahead.
Yeah, sorry about
Yeah.
that.
Yeah, no worries. Yeah, so just because I think my research or getting into research was a bit more recent. So like I said, I'm a senior at Wellesley College, 4th year. And I actually got into research during the summer after my sophomore year. So Wellesley College has this really great program that allows for students to look at projects that professors are doing and they kind of get recruited into them. And so they open up this website and it's just a list of all the projects that professors do. And at the time, I was very interested in like social media research and kind of how different communities work, and then how you can like quantify their differences. And Professor Catherine was doing something very similar to that. So I was like, oh wow, this is so interesting. I applied for that. I was able to work with her during the summer, along with 2 other like amazing lab mates. And then I continued working with her throughout that school year. And the next summer, I also continued working with her. But I also was lucky enough to be in a class with Professor Christine, or an algorithms course. And we kind of got to talking about, algorithms and fairness, like how you evaluate them, which was something she was also doing research on. And so I joined her lab as well over this past summer. And so, yeah, I don't have quite the long tenure of research, but that's kind of been my journey so far.
Awesome. Yeah, thank you so much for sharing. Daniel, did you want to share as well? No pressure, but I just wanted to give you an opportunity.
Yeah, sure. Yes, so I did a bit of web application development. Sorry for the background noise, by the way. But I did a bit of web development in high school, and then going into my first year, I did a summer program, and Nima was actually one of the professors teaching for it. And I felt like always I wanted my web application work to be applied, and Nima was working on some bioinformatics stuff. And yeah, I just kind of, it was like there was a final project for the summer program, and I just didn't really have any ideas, so I asked him if he had any ideas or anything I could work on. And I ended up building like a visualization tool. But then I think going into the first quarter of my first year, I kind of just kept on doing the work. And now I'm working more with like the WebAssembly tools or WebAssembly and kind of taking tools from like mainline, putting them on the browser. And now even like building potential database tools that kind of use both server side tool like scripts to run tools, and then also on the browser side to run some that are less or just better, make more sense for the web browser. But yeah.
Awesome. Thank you. Thank you. Yeah, thanks everyone for sharing. So I guess that kind of leads me to my next question. So I heard some glimpses of like what types of factors went into what led you all to your point, but like to your current position or research topic. But for an undergraduate who's kind of still taking classes and kind of still in the early days of their undergraduate career, what advice or kind of what insights would you have in terms of how does someone go about finding a mentor and also finding what research topic they're interested in? Aside from stalking people, obviously, but maybe that's a fun thing to do too. But yeah, no, how do you go about finding who could be my mentor and maybe what topics am I interested in? Maybe just open to anyone. Feel free. I guess maybe actually, if the undergrads are open to it, maybe I'll ask either of you since you're more recent. How did you go about? So Daniel mentioned that he did the summer program, so we just kind of happened to be together. But I guess Sophia, like how did you go about even finding these opportunities? And then maybe Daniel as well if you want, but
Yeah, I can definitely talk on this. So for my work with Professor Catherine, it was, I think, just seeing her project and being so aligned with interests that I already had kind of developed. That was what led me to her. But then with Christine, I think it was because like we had a class together and I was able to get talking with her. And it was something like we were, both very interested in, which kind of led me into that research. But I know other students, like the NSF-RU website is a great way to get into research, because you can kind of see what kind of research is being done. You can kind of scope out what you might be interested in, and then do, further research on that to see, what colleges are doing research on that, or maybe what departments or even specific professors are doing that. And if you're like really into it, you can cold email the professor and be like, hey, I love your research. Would you be open to chatting about it? And perhaps that can lead to like a research position. But I think just really just researching your passions and kind of seeing where that kind of thing is being looked into is a really good way to get into it. And then talking to people, like even if it's not for the purpose of getting like a position, just talk to your professors about their research. Like I think they really, they're really into it. So they like sharing that with students.
Thank you so much for sharing. Absolutely. We're humans. Talk to us, please. They maybe like talking about the research too much, so you might not be able to get us to stop. I don't know if Daniel, if you also wanted to chime in on your experiences.
Yeah, sure. I think I got pretty lucky with kind of my work overlapping with Nima's, but I think maybe something before even looking into the research is just finding something that you like to do. And I think maybe a big factor that I was able to kind of do the research I'm doing now was kind of just picking up web development. I feel like if I didn't know as much, then it might not have been as easy kind of hitting the ground running in research. So I feel like just finding something that you enjoy and are interested in, and then taking your own kind of dive down whatever field you're interested in, and then having something to kind of possibly contribute or work with for the professor, definitely finding. And that's it.
Awesome. Thank you so much. I don't know if any of the, yeah, Roman, please go for it.
Yeah, I want to just echo what Daniel was saying. I think that following your curiosity is so important. And, a lot of the panelists have already kind of spoken to the serendipity of the paths that have led up to where they are today. I think if you follow your curiosity and you're open for these opportunities, they present themselves to you, there's not going to be like a formula on how to get there. It's going to look different for every individual, right? Some people will very much just keep diving down that one deep path. Other people, I'm very much like, Celeste's experience resonated with me, where I've kind of taken this meandering path that has taken me to, material science and energy, materials like cathodes and solid state oxides, to lithography and industry, right? UV lithography and even quantum computing. But if I were to flash all the way back to when I was an undergraduate, I would say an internship is an invaluable experience. For me, that first internship that I took, I had taken a material science course, and I knew I was interested in that, but it was, one of many courses, and it didn't stand out to me that direction until I took on this internship. And I still remember the R&D engineers at the time were working on depositing a carbon coating to a sewing cup on an artificial heart valve. So the sewing cup is the piece that they actually sew into the heart, right? And so it has to be soft, but to make it biocompatible, they had a physical vapor deposition process of carbon on that sewing cup. And to me, like, that was just the connection of the concepts that I was learning in this introductory material science class to the R&D. And then just, I didn't get to experience the part of, turning those R&D experiments into a product because it was just an internship. But my curiosity was just off the charts that I wanted to do more. I was hooked. So just if I could boil it down to one piece of advice, is follow your curiosity. And an internship is just a great avenue to do that and really dig a little bit deeper and really see if you like it. And you might surprise yourself and go off in a 90-degree direction somewhere you weren't expecting.
Oh, yeah. Thank you so much. Yeah, Celeste. Yeah, sorry. Please go for it.
Yeah, I might throw in one other thing that I think helped me when I was an undergrad, and what has really stood out to me of young people and more junior people who I've worked with, is that it's one thing to send an email and cold call and be really enthusiastic. And it is another thing to continue that enthusiasm and to be self-directed enough, because that's one of the big challenges, is that especially when you're a student, people are so excited to help you. Well, like if you have a student email, everyone is so excited to see you succeed. But just to be frank, what I have seen happen a lot of times is I'll get 1 email, 2 emails, super enthusiastic, and then never get a response. And it becomes really challenging to invest in someone and then not have them actually follow up on it. So what I would make a big guess from what both Sophia and Daniel have both said is that they both sound like they continued and they were very self-directed in their research. And that makes it so much easier as an advisor to invest in you. And so I think, you know, you got to come with the passion, you got to come with the enthusiasm, but you need to do it at a level that you can maintain. Because, right, you're going to have classes, you're going to need to be self-directed enough to push yourself to do this when you don't have a deadline, when you're setting your own deadlines. And so I think making sure you are interested enough to like actually answer your emails. That's all I want. Answer your emails. That took me a long time to learn.
Oh, I can echo that as a professor that never gets responses to a lot of my emails. So that resonates with me very hard. I don't know, Christine, did you want to, I think there was a good question you wanted to ask in the Q&A.
Yeah, sure. I don't know if Catherine, did you want to jump into that question too before I answer mine, or?
Explain REU and DREU.
Yeah, so no, no, not that one. I'm sorry. No, I meant, so there was a question. Okay, so I'm going to read the question from the Q&A. It says, as an international student, because it was linked to the REU stuff. I found that a lot of opportunities are government funded and therefore are not eligible for non-citizens or permanent residents. How would you recommend searching for opportunities in this case?
Oh,
You
I
want to
can.
take that? Okay.
Sophia, do you want to?
I have some recommendations. So there are a lot of fellowships for research in particular is much easier for international students, or if you're not a US citizen, to get into. There's a lot of fellowships that don't require citizenship. I believe it's called Pathways to Science .com, and it has it's a good way to like filter for research that you want, and there's a filter you can use on it that will like give you, thank you, put it in the chat, that you can like filter out the ones that do require citizenship. Industry, you know, you can go into it, it's very competitive right now, but research I found in general seems to be easier to get into. But disclaimer, I'm not a international student, I just have a lot of friends who are, so yeah, this is kind of secondhand from them.
And in addition to having done research with me and Christine,
Mhm.
Sophia has also done a lot of research on different paths that students take for summer opportunities. So she's very knowledgeable on all of this too.
Yeah, thank you so much both for sharing.
you.
I don't know if anyone else wanted to add any opportunities, or feel free.
I'm just going to make a plug here for the semiconductor industry. Maybe as a student, you may have seen some headlines of this large CHIPS funding act that Biden passed, right? So this is, the government actually got together, Republicans, Democrats, agreed on something, and that agreement was $52 billion for the semiconductor industry. Now, a lot of that is just the onshore manufacturing, but about 12 billion of it is for R&D. And one thing that everybody can agree on, both in government and in academia and in industry, as far as semiconductors go, is that there's a huge shortfall of workers. This includes everything from technicians to manufacturing engineers to R&D engineers. So, you know, by some estimates, we need to grow the workforce to meet all of these investments by 3x. So, you know, if you can imagine the supply and demand dynamics of that, there's going to be a lot of jobs for researchers in the semiconductor industry. So if you're looking, if that draws your attention, you want to learn more about it, try to find those internships. I think it's a good time. It's kind of a pivotal time where many opportunities are going to exist for the next several decades in that area. So that's my plug to students that are thinking about a career. If you're curious about that, follow your curiosity a little bit more and see if it's something that resonates with you.
Awesome. Yeah, thank you so much.
Thank you. And if you guys don't mind, I could also add a little answer to that as well, that sometimes it's helpful to also ask about the opportunities within your institution, within your department, within your school, because sometimes, the professors have funding, and that funding is not limited to citizens or nationals.
Awesome. Yeah, thank you, folks. Yeah, great discussion on that. So I guess I'll maybe ask one more question, and then we can maybe just broadly open the floor to the audience, but still, audience, feel free to keep typing questions in the chat and in the Q&A, and we'll keep an eye on it. But I guess my last question on this front would be like, why are you still doing research, and like kind of what kept you going? So you got sparked interest at the beginning. Like, what about it makes you so passionate about it? And I guess maybe kind of an extension of that, like, what advice do you have for students wondering if they want to do research? Like, what questions should they be asking themselves? So I guess that's kind of a two-parter, but yeah, why are you still doing research, and just what questions should people have in mind if they're considering it? Yeah, Celeste, please go for it.
I'm gonna hop on this one first. I would say the reason that I'm still doing research is because I like working on a problem that I'm pretty sure no one else has maybe ever worked on before. And right, there's a whole bunch of, some people might be working on it at the same time, and then you got to publish first, whatever, right? But nevertheless, it's kind of at the edge of what is going to be happening in science or whatever domain that you're working in, which is pretty cool. I would say that is what makes me continue to work in research. I would say if you're considering and you're trying to figure out whether or not you like research, this has kind of been my test. But a lot of our students are on this panel are in computer science, right? They're studying computer science. Okay. I would say that one of the big determinations is sometimes you're going to get onto a project, but for school or for whatever, and there's going to be times where you're looking at this project and you're like, am I dumb? Like, is this dumb? Like, I am so completely stuck and I have no idea what my next step should be. And I think for me, one of the determinants that made me realize I like research is that I am extremely motivated to get over that feeling. And I'm not saying this is like a moral pro or con or anything like that, but if those are not right, with research, you don't have a determined answer. What you're doing might not work. There's not a guaranteed path to success. And so if you enjoy the feeling, I don't think anyone enjoys that feeling of frustration, but if you are really motivated by the feeling you have after you've overcome that, I think that is a good indication that research might be well aligned with your personality. But it's also just as valid that if you want a path that is more likely to be successful, if you want a path that is more likely to get into the hands of consumers and to more definitely go somewhere, then research might not be the best path, but that means that you could be a great engineer in kind of a production environment or something like that. But I would say if you like working on projects with problems that are not guaranteed success, research could be good for you.
Awesome. Yeah, thank you for sharing that. Absolutely. I wholeheartedly agree with that. Awesome. Yeah, anyone else want to give their insights? Yeah, Roman, please go for it.
Yeah, sure. I mean, I think that for me, one of the factors that has kept me in research in one form or another is I love to be learning, like, so just continuous learning. And that goes, even before starting a career in industry. I think one of the big realizations for me was, graduate school for the first time wasn't about the classes anymore. Like Celeste said, you're learning things that it's not in the books yet, right? So you start to stop getting away from the textbooks and you start diving into the research that hasn't made it into textbooks. You're reading more papers. You might have a crazy idea that there's not even a paper on, and you just have to figure out, well, how do I test it if it's even like worth me spending more time on? And it's just that process of realizing that lifelong learning doesn't mean you're in a classroom. It's actually quite the opposite. You make this transition through graduate school, where graduate school is that time and place where you learn that the real learning happens outside of the classroom, in the lab, on your own, following ideas, and also collaborating, right? You also want to know what those other people that are thinking in parallel ways to you, what they're doing. And then I would say just one other thing in my career that's been really cool is in industry, you start to work on problems that are much bigger than one person or even a small group of people could tackle. And, if I look at my, 17 years at Intel, it's been a slow progression of, you land and you know how to figure out problems maybe on your own, and you're good at that, but you immediately have to learn how to work with a team of 12 people. And then as you progress more in your career, after 10 years, you realize, oh, you really can't get anything done with 12 people. You need to be collaborating on a bigger scale. And that's how, the great things are done. This sounds kind of cliched, but It took a lot more than a dozen people to put a man on the moon. It's taken a lot more than, 100 or 1,000 or even 100,000 people to put all of the GPU chips in the data centers that are powering all of your AI applications today on your phone, in your search engines. So just that realization that following a research career lets you go super deep, but at the same time, makes you open your eyes to how powerful collaborating and teamwork is. That to me is that's what keeps me in research. And I think if you go down that path a little bit, it'll keep you in research too.
Awesome. Yeah, thank you so much for sharing. Absolutely. Anyone else on the panel, feel free to jump in. No pressure though, no pressure. Awesome. Yeah, thank you. Maybe Christine, yeah, go for it.
All right, so thank you, everyone. This was excellent. I mean, really, we have other questions prepared, but we want to open the floor, to everyone, or open the room to everyone of all the students here who might have questions. So please, please, please feel free to raise your hand, unmute yourself. We can talk. Like this is like a regular Zoom meeting. So feel free to, just jump in, unmute yourself, ask a question. If you don't want to, please send it in the Q&A. You can send stuff anonymously. No one will know anything. And I'm the only one who sees them. Actually, just a few of us will see them. So feel free to ask questions, any questions. And, we'll love to chat more. Nothing yet. Okay, I'm going to assume that people are typing. I mean, I have a question in the back of my head, but I want to wait and see others. Okay, should I ask my question? Maybe I can jump in, ask my question until people type in their questions. So I'm going to give you more time to type. It's okay. So one question I wanted to ask was, I mean, we've talked about a lot of amazing things, and I like to ask that little tricky one, which is if you had any challenges while doing research or that you're comfortable sharing for our panelists. Can you describe one such challenge and what kept you coming back to research despite that challenge? So, just talking about, the road is not always easy and clear. There's a lot of things that happen along the way. So if anyone wants to share, challenge or two.
I mean, I can talk on
Celeste,
one.
go ahead. Okay.
Oh, go ahead.
Okay, Sophia, go ahead.
I think this is just one that you're always gonna face coming from maybe more like traditional like schooling into research, is that like some people have mentioned before, is it's very much unstructured compared to like class projects. So you do have to have motivation yourself to do things. You do have to plan it out yourself. Like you create the deadlines. Like there is no deadline for you planning the deadlines. Like you just have to do it. And like there are ways to create like structures around yourself, like keep yourself accountable, like having mentors who will like be like, okay, check in with me 2 weeks from now. But just stuff like that, where a lot of the assignments are you're coming up with the question, the prompts, the actions, and you're also coming up with the metrics to say, oh, how good did you do? Like it really is a lot of self-driven stuff that I think can be a little hard to adjust to, like coming out of like say an undergrad course. I'd say like I kind of liked that part because you're able to build what you want, and it's much more variable than like written description of what you're supposed to do. But it can be a bit of a change. Yes.
Oh, thank you for sharing that, Sophia. Celeste, do you want to?
Yeah, I'll be honest. I think I chose my master's research very poorly because I went straight from undergrad and I knew that I wanted to keep studying, but I basically just found a professor that I liked and said, okay, I think power grids are kind of cool. And ultimately, I worked on something that didn't really, I was aligned with it because it was renewable energy, that felt good, that felt aligned with my values. But ultimately, I was doing a bunch of simulation work. Like I just chose badly. It was research that was available to me. It was not research that I had chosen because I had a specific question I wanted to ask. I was not as directed as perhaps some of our undergraduate panelists were, and I didn't know exactly what skill sets I was trying to get out of it. And I'll be honest, when you're in an academic setting, I'll keep this quick because I know some questions came in, but there is a power dynamic with your advisor. And I think the biggest and most determinant thing you're going to do if you go for graduate school is choose the personality of your advisor, because they have the power to determine the next 5 or 6 years of your life. And I think there's a big element of that, particularly if you're an international student and they hold the keys for your visa. So I just want to be transparent about, like, the school name doesn't matter. The research is almost ancillary compared, well, I know I just said the research, you have to figure out what you want. But the person who's going to be guiding you is probably the biggest choice you're going to make for your advisor, for your manager, for anything. So that took me a long time to learn. So I hope that you will not make that mistake.
Love that. Thank you, Celeste. Thank you. And actually, that links very well with the question that was already asked in the chat of, like, what makes one an ideal candidate for advisors? So you're saying about thinking about, how would you pick your advisor, but also how would advisors pick you? I don't know if anyone wants to jump in. No.
I can jump in. I'm not on the panel formally, but I can chime in. I mean, I think for me, when I was in my PhD program, and just in general, all my research experiences, I think a big thing is, do you kind of mesh well with their working style? So for me, I don't really like working 9 to 5. I like kind of working at my own pace. Just give me deadlines or kind of progress updates and I'll meet those. Versus like some of my friends from grad school really liked structure, come into the office at 9, leave at 5, and they liked kind of having it be a regular 9 to 5 job. So the advisors that they chose structured their labs in this kind of company-esque structure where you kind of show up on time, leave on time, go to the right meetings, all that stuff. Versus my advisor was a lot more hands-off and kind of just let me do stuff at my own pace as long as I made progress regularly. So I think kind of self-reflecting on your work style, your kind of, I don't know, just social style, kind of all aspects of what makes you vibe with someone, whether that, whoever that person is, kind of take those things into account and then try to find an advisor that you think you could vibe with in some way. Their work ethic matches yours, their expectations match your expectations, all that good stuff.
Thank you. We're getting a lot of great questions in the chat. So if you guys don't mind, I'm gonna move on. I think there's a good question that was asked earlier. Are there big differences from industry R&D and university research?
Yeah, Roman, please. Roman, please.
Yeah, I mean, I think I can say a few words on that. At least the relative importance of publishing papers is very different, right, in academia versus in industry. And now there's a lot of different types of R&D across industry. So, rather than trying to talk about all of them, I'll just tell you a little bit about the culture at Intel, right? So Intel has 2 R&D groups. One's called components research, and that's the manufacturing side of the house. So like in the lab, in the fab, building devices, building chips. This is on everything from small coupons to 300 millimeter. So a lot of that is publishable research, and it gets published, sometimes even in collaboration with a university that we're collaborating with. And then there's other research that maybe if it's further along, it doesn't get published. And maybe it gets patented, or maybe it's just secret and we don't talk about it. So that's quite different than in university, where the focus is on, high impact journal, disseminating your results, being the first one to kind of break new ground. And, sometimes you hear, I think incorrectly, people say, well, if you stay in university, you can explore your ideas and have all of this freedom. And that's not really, there are different constraints, right? I think in academia, you have to apply for grants to get the money to be able to pursue certain ideas. So you're constrained by the grants that you write and the ones that end up getting awarded. If you're a student, you're going to be constrained by those constraints from the advisor that you work for. And that's not to say that in industry, there aren't constraints, right? Like Intel's not going to let me continue to do research on lithium-ion batteries, which is something I did in grad school. Once I was in components research, I had to learn how to take what I had learned about solid state oxides and apply it to EUV lithography. But I think the further along you get in your R&D career, you'll realize that those connection points between what seem like very wildly different topics, they exist, and you can bring your expertise into many different realms and be an asset to that team. And then just to get back to your question, what's the other big difference in industry R&D and university research? From my perspective, the industry R&D is a lot more collaborative and a team effort. And that's because when you're competing for that publication in a high impact journal, you have to have like some amount of like secrecy from the other groups. Yes, you're collaborating within your academic group, but it's usually a smaller group than a team of like 100 people or something like that in a big R&D industry lab. And that's just my perspective. I think someone from the academic side might see things a little bit differently. But wanted to share that.
Yeah, I'll add a little bit to that. To me, so just for a little, like maybe a lesser known place to do research is a liberal arts institution like Wellesley. And there are many others like this, but we don't have much of any grant writing requirement as part of our tenure track position, which I find to be a benefit of a position like this. We get to work with great students and do research that gets published in top venues in our areas. But there are a lot of resources that we have available at our school to support students, like say through summer research programs and things like that. So there are ways to do varieties of research like this, it being in academia, but maybe not having as much of some of those downsides. If people don't like grant writing, for example. Yeah.
Great.
Awesome.
So
Yeah. Oh, sorry, Christine, go for it.
no, go ahead, team.
Yeah. So thanks everyone. So I do want to be mindful of panelist time, so I don't want to stick too long. So there was, I think, another question that was in the chat that I think we can stay on if folks want to still ask a couple questions, but I do want to give the panelists a little bit of time to head out. I do really quickly before anyone leaves, I want to plug, I don't know, Julia, did you want to pull up the survey, or if Christine has the survey?
I can share that survey real quick.
Just to be mindful of folks that have to head out at 4.
Sorry, trying to find my window. There we go. So quickly just playing in that there are 3 more sessions coming up, one March, 1 April, 1 May. So please stay tuned. Just keep an ear out for our emails. And there's more to the programming that is offered by the CRA. There's a lot of other cool stuff that the UR2 PhD program is offering. And then this is the survey that Nima mentioned. So please, would love to hear from you. Just, scan that QR code, give us your feedback. Julia?
Yes, and then once this meeting ends, it may open up in your browser. So if you don't have a chance to scan the QR code now, it will automatically populate.
Okay.
Oh, fancy.
Let's see.
I have to learn your Zoom techniques.
I was just going to say fancy as well. Maybe we should learn how to do that.
Yeah.
Thank you, everyone. And really, please, thank you so much. Please give a round of applause for our panelists. Thank you.